Let's start with a discussion about Windows security. So Windows security model is really complicated, but in a nutshell, it focuses on three important components. So on one side, you have system resources like files, directories, or registry, okay? On the other are the users/processes which want to use these resources. And by saying users/processes, I mean that processes are run on behalf of the users, okay? Now, in between resources and processes, we have system kernel deciding which process can access which resource. That's basically how this model works. Now, how access to the resources is granted or denied? So each resource has its security descriptor, which is composed of an owner, a group, and some access lists, which describe who can and who cannot access the resource. On the other hand, processes use access tokens, which are dedicated objects describing user's identity. And security reference monitor in the kernel checks if a call from a specific process to access specific resource is allowed or not. Now, how is it done? So there are a couple of steps SRM does. First, it verifies an integrity level of a caller, and the integrity level is just a sort of number assigned to both tokens and resources. If integrity level of a process is lower than the one of the resource, access is denied, okay? Otherwise, SRM proceeds with checking the owner and access list of the resource. Now, there are a couple of integrity levels in Windows. We have low, medium, high, and system. Usually users run in medium integrity level, and when they need to do some admin work, like install software on the system, they have to be elevated into high integrity level to do that, okay? And system services receive system integrity. Now, access tokens are the foundation of all authorization of decisions on the operating system. They are granted to authorized users by the local security authority, also known as LSAS process. And each access token includes the user's so-called security identifier, or SID, which is some sort of a number, okay? It also includes some group SIDs user belongs to, some privileges, user's integrity level, and other security relevant information. Now, every process or thread created by a user inherits a copy of their token, okay? Access tokens may exist as primary tokens or impersonation tokens. Primary tokens are used to present the default security information of a process or thread, and impersonation allows to perform an operation using an access token from another user. Impersonation tokens are typically used in client-server communication, okay? So, for example, when a user accesses an SMB file share, the server needs a copy of the user's token to validate that the user has sufficient permissions, right? Now, let's talk about privileges. Privileges determine the type of system operations that a user can perform. And these are things like shutting down the system, loading device drivers, or changing the system time. Now, privileges are something different from access rights. There are two main differences. Privileges control access to system-related tasks, whereas access rights control access to securable objects. And these are like files or named pipes or network shares or even access tokens, okay? The second difference is that privileges are assigned to user and group accounts, whereas access rights are assigned to objects access control lists. So these are two main differences you have to understand, Okay? User access control is a component of Windows security, and the idea behind UAC is really simple. So if a user wants to perform administrative action which requires a change in its integrity level, the system will ask for admin credentials, okay? And if user is already a local admin but runs in medium integrity level, then a simple pop-up will show on the user screen to get his consent for administrative action. Oftentimes, users are assigned with local admin privileges, and when their machines gets compromised, the attacker can become local admin as well, right? But UAC blocks easy access to high integrity level. So an attacker has to find either UAC bypass or some way to completely turn UAC off. Okay. So how UAC corresponds with token privileges? So there's a so-called restricted access token, also known as filtered admin token. It is a subset of primary or impersonation token that have been modified to control privileges or permissions. So let's see how it looks like on the examples. So on the left side, we see a CMD session of a local admin running with privileges from restricted token, okay? And in the right side, we have an elevated admin session with much larger list of available privs, right? So even though user on the left is running as a local admin, he cannot do much. And to get elevated to more powerful position, he has to go through UAC, okay? And here's where all the fancy UAC bypasses come into play, but we will cover it in a later time. Now, privilege escalation is not only about getting system privileges. There are other degrees of the flavor. So we're talking about becoming another user by stealing someone's password or running in his security context or session. It's about changing integrity levels from medium to high or from high to system. It's also about abusing owned permissions or privileges to get more powers or gaining more privileges. And talking about the latter, there are some privileges, so-called dangerous, which can be misused to break out. And these are backup, restore, debug, create token, load driver, take ownership, and TCB, or trusted computer base privileges. If you have one of those, you could potentially become full system process, and we will cover some of more advanced techniques describing how to do it, okay? During the course, we're going to cover several paths of privilege escalation. So starting from non-admin, low privileged user running in medium integrity without any password, we'll go through getting credentials of the running user or other more privileged users in the system. Sometimes getting a password doesn't give you direct promotion to higher integrity level, but it might be helpful to eventually reaching higher privileges. We'll also see how to become local admin and with and without changing integrity level. Apart from that, we will cover techniques of becoming a system user starting from different levels, either from non-admin, admin, or even a service account. One thing worth to note here is that each technique will be preceded with a slide showing which path we are taking with specific method.